February 14, 1943, 0947 hours, 18,000 feet above Guadalcanal. Lieutenant Commander Saburō Sakai, veteran of 64 confirmed aerial victories, peered through the canopy of his Mitsubishi A6M0. Through the morning haze, he witnessed something that defied his understanding of aerial combat. An American fighter, bent-winged and ungainly, rolled inverted and dove past his formation at impossible speed. The maneuver violated every principle Sakai had learned in 7 years of combat flying. No fighter that large should possess such velocity. Sakai keyed his radio transmitter, new American type, inverted gull-wing, speed exceeds 400 knots in descent. What Sakai didn't know, what none of the Imperial Japanese Navy Air Service could have imagined, was that this single aircraft type would destroy Japanese air superiority across the Pacific in 18 months. Within that time frame, the Chance-Vought F4U Corsair would achieve an 11-to-1 kill ratio, transforming Japanese tactical dominance into systematic annihilation. The mathematics of aerial warfare were about to be rewritten in fire and wreckage across 10,000 miles of ocean. Japanese naval aviators had been trained to believe that maneuverability determined victory. Their doctrine emphasized tight-turning combat, prolonged engagements where superior pilot skill would prevail. The Zero's ability to outturn any Allied fighter had confirmed this assumption through 3 years of conquest. American industrial capacity seemed irrelevant when Japanese pilots consistently shot down 4 or 5 enemy aircraft for every loss. The Corsair shattered that calculus. American designers prioritized speed, firepower, and survivability over maneuverability. The result was a fighter that refused to engage on Japanese terms, that could choose when to fight and when to disengage, that delivered overwhelming firepower in seconds before escaping beyond pursuit. The philosophy that had conquered half the Pacific became a death sentence when facing American engineering. Imperial Japanese Navy doctrine emerged from 2 decades of aggressive aerial theory. The Combined Fleet Air Training Manual emphasized spiritual strength and aircraft performance that maximized agility. Japanese designers created the Zero with a single purpose: dominate through superior maneuverability. The aircraft could outturn any contemporary fighter, climb faster than American or British types, and achieve greater range than Western engineers thought possible. Early Pacific victories confirmed Japanese assumptions with brutal efficiency. At Pearl Harbor on December 7, 1941, Zero fighters destroyed 188 aircraft while losing 29 of their own. During the Philippines campaign, Zero pilots achieved kill ratios exceeding 10-to-1 against American P-40 Warhawks. Over Java, in February 1942, Japanese fighters shot down 42 Allied planes while losing only 7 Zeros. At the Battle of the Java Sea, Japanese naval aviation demonstrated complete air superiority. Over Burma, Zeros destroyed 115 Royal Air Force aircraft while losing 12 fighters. These victories built fatal confidence in Japanese tactical superiority. The ideological foundation ran deeper than military success. Admiral Isoroku Yamamoto publicly stated that American pilots lack the spiritual strength for prolonged combat. Vice Admiral Chuichi Nagumo declared that democratic chaos prevents coordinated military excellence. Japanese training manuals described American aviators as soft, accustomed to luxury, unable to endure hardship. Intelligence reports dismissed American industrial claims as propaganda designed to mask military weakness. Japanese intelligence officers received accurate reports about American aircraft development. Throughout 1942, naval attachés in neutral countries documented Corsair test flights, noting specifications that exceeded Japanese capabilities. Commander Yoshio Shiga, naval attaché in Switzerland, transmitted detailed reports about American fighter development to Tokyo. Imperial headquarters dismissed these reports as disinformation. Officers who insisted on accuracy faced reassignment. Commander Shiga received a reprimand for defeatist analysis. The truth was too threatening to be acknowledged. Admiral Jisaburo Ozawa, 58, commanded carrier aviation for the combined fleet from his headquarters in Truk. Veteran of naval aviation since 1920, Ozawa believed absolutely in Japanese tactical superiority, convinced that superior pilot training and spiritual discipline would overcome any material disadvantage. He had been taught that technology served the warrior spirit, not the reverse. Commander Minoru Genda, 39, architect of the Pearl Harbor attack, served as air operations officer aboard the carrier Zuikaku. His pre-war experience included studying American naval aviation during a posting in Washington. Genda designed Japanese carrier strike doctrine, emphasizing coordinated attacks and fighter superiority. He calculated that maintaining air control required a 3-to-1 numerical advantage, a ratio Japanese training quality could sustain despite American production. Lieutenant Commander Tadashi Nakajima, 32, from Hiroshima, commanded the 251st Air Group's fighter squadron based at Rabaul. A veteran with 19 confirmed victories, he had flown the Zero since 1940, knowing every capability and limitation. His pre-war career as a test pilot gave him technical insight beyond typical line pilots. Nakajima believed the Zero's maneuverability made it invincible in expert hands. Lieutenant Commander Saburō Sakai represented Japan's elite. At 27, with 64 victories, Sakai had survived combat since the first day of war. The farmer's son from Sakai had spent 12 years mastering aviation before seeing combat. His experience included battles over China, the Philippines, Java, and New Guinea. Sakai believed tactical skill would always defeat industrial quantity. Captain Masataki Okumiya, 41, served as senior staff officer for the 11th Air Fleet at Rabaul. The Tokyo native had graduated from the Naval Academy in 1924, spending 18 years in aviation positions. His analytical mind made him valuable for strategic planning. Okumiya maintained detailed combat records, tracking losses and analyzing patterns. Lieutenant Saburo Obyogi, 24 fighter pilot in the Tainan Air Group, kept meticulous combat diaries from Rabaul. His 12 victories came from the prolonged turning fights Japanese doctrine demanded. Obyogi's diary entries from early 1943 expressed confidence that American fighters remained inferior. Lieutenant Tetsuzo Imoto, 28, from Hokkaido, commanded a division in the 204th Air Group operating from Munda Airfield. With 14 victories by February 1943, Imoto specialized in high-altitude interception tactics. His background as a commercial pilot gave him perspective on aircraft performance and reliability. Lieutenant Commander Takeo Shibata, 36, Chief Engineering Officer for Carrier Aviation, worked from Yokosuka Naval Arsenal. The Osaka native had studied engineering at Tokyo Imperial University. His expertise in aircraft design made him responsible for evaluating enemy capabilities. Shibata believed Japanese engineering philosophy produced superior aircraft despite limited resources. Warrant Officer Kiyoshi Ito, 26, from Osaka, served as an aircraft maintenance specialist with the 582 2nd Air Group. His pre-war career as a civilian aircraft mechanic gave him expertise in structural design. Ito had examined captured American aircraft, noting their robust construction, but his commanders dismissed his observations as irrelevant. Petty Officer First Class Hiroshi Matsumoto, 23, served as an armorer at Rabaul. The weapons specialist from Nagasaki maintained and loaded the Zero's armament. Matsumoto believed Japanese marksmanship training made heavier American armament unnecessary. Petty Officer Second Class Kenji Tanaka, 21, worked as a radio technician with the 251st Air Group at Rabaul. His duties included monitoring American radio traffic and maintaining Japanese communication equipment. Seaman First Class Yoshio Nakamura, 19, served as a mechanic's assistant at Rabaul. With 6 months of experience working on Zeros, his limited technical knowledge came entirely from on-the-job training. He had been told that Japanese aircraft were the finest in the world. Flight Petty Officer Junichi Sasai, 25, flew as wingman in Lieutenant Iwamoto's division. With 8 victories, Sasai represented the competent but not exceptional pilots who formed the backbone of Japanese fighter squadrons. February 13, 1943, fighter pilots of the 204th Air Group scrambled from Munda Airfield to intercept American bombers. Lieutenant Iwamoto led his division of 4 Zeros toward the bomber formation at 15,000 feet. Through scattered clouds, Iwamoto spotted escort fighters climbing to meet his aircraft. The silhouettes appeared wrong. Broader than Wildcats, the characteristic bent wings immediately identifiable. Iwamoto initiated the standard Zero tactic, a high-speed climbing turn positioning his formation above the Americans. The American fighters continued their climb, matching the Zero's ascent. This violated Iwamoto's combat experience. American fighters couldn't outclimb Zeros. At 20,000 feet, the American fighters dove, not cautious descent, but aggressive plunge that built speed far exceeding anything Iwamoto had encountered. The Corsairs reached 400 knots in their dive. Iwamoto's Zero topped out at 330 knots in level flight, perhaps 360 in a dive. The mathematics of pursuit became impossible. The technical specifications behind this performance came from design philosophy that contradicted Japanese priorities. The F4U Corsair weighed 14,000 pounds fully loaded, nearly double the Zero's 6,500 pounds. Its Pratt Whitney R-2800 double Wasp engine produced 2,000 horsepower, compared to the Zero's 1,130 horsepower Nakajima Sakai engine, where Japanese designers minimized weight to maximize agility. American engineers built a fighter around the largest available engine. The Corsair's armament philosophy reflected similar thinking. 6 Browning M2.5T caliber machine guns, each loaded with 400 rounds, provided 2,400 rounds of ammunition. Total throw weight exceeded 28 pounds per second when all guns fired. The Zero carried 60 rounds per 20mm cannon and 680 rounds per 7.7mm gun, roughly 30 seconds of firing time with careful trigger discipline. Iwamoto attempted to engage the Corsairs as they pulled out of their dive. His Zero turned inside the American fighter's radius easily. The Corsair pilot didn't attempt to turn with Iwamoto. Instead, the American pushed the throttle forward and climbed away at full power. The Zero couldn't follow. Within seconds, the Corsair escaped beyond effective range. The engagement lasted 4 minutes. Iwamoto's division expended most of their cannon ammunition without achieving a single hit. The Corsairs destroyed 2 Zeros, killing both pilots instantly. Flight Petty Officer Sai watched his section leader's aircraft disintegrate under .50 caliber fire. The wings separated from the fuselage, the fuel tanks exploded, and the wreckage tumbled into the ocean. Lieutenant Iwamoto's combat report filed that evening stated, "New American fighter type demonstrates performance exceeding our aircraft capabilities. Speed and climb rate make interception difficult. Armament appears to be 6 heavy machine guns. Armor protection prevents our 7.7mm rounds from achieving damage. Recommend tactical study." Commander Nakajima read the report with skepticism. A single engagement couldn't overturn 3 years of Japanese air superiority. What Nakajima didn't know was that Iwamoto's encounter represented the opening moves in systematic destruction of Japanese fighter capability. But this was merely the first shock. Within 3 weeks, combat reports from across the Solomons described identical encounters. At Bougainville, Zeros attempting to intercept Marine bombers met Corsairs that dove through formations at speeds the Japanese couldn't match. Above Rendova, a full squadron of Zeros engaged 6 Corsairs in what should have been decisive numerical advantage. The Corsairs dove, fired, climbed away, and repeated. 5 Zeros crashed without the Americans entering a turning fight. Commander Genda reviewed the reports aboard Zuikaku with growing concern. The consistency troubled him more than individual encounters. Different pilots, different locations, identical outcomes. This suggested systemic performance advantage rather than pilot error. Lieutenant Commander Shibata examined what intelligence existed about the Corsair. American radio broadcasts claimed the fighter could exceed 400 miles per hour, climb to 20,000 feet in 7 minutes, and carry more ammunition than any previous American fighter. Shibata calculated that achieving those performance numbers required an engine producing at least 1,800 horsepower, perhaps 2,000 horsepower. No nation fielded such power plants in operational aircraft. The specifications had to be propaganda. Shibata calculated that building engines of that power required forging capacity, precision machining, and metallurgical expertise. Japan struggled to maintain. American factories would need hundreds of specialized machine tools, each working to tolerances measured in thousandths of an inch. Japanese craftsmen spent years mastering their trades. American workers were housewives and farmers playing at industrial production. Yet combat reports continued. By April 1943, Japanese pilot accounts described Corsairs as invincible in certain tactical situations. Lieutenant Aoyagi recorded in his diary on April 18th, "We intercepted American fighters today. My division positioned perfectly for attack, above and behind their formation. We dove to engage. They saw us, accelerated away. We couldn't catch them. They climbed back to altitude, dove again, and killed Nakamura-san. We never had a chance to use our advantages. The industrial reality operated 6,000 miles from Rabaul, Stratford, Connecticut, housed Chance Vought's main production facility. The factory covered 1.2 million square feet of floor space, constructed in 9 months during 1941. The building contained 3 parallel assembly lines, each capable of producing 1 complete F4U Corsair every working day. The facility employed 12,800 workers, including 2,800 women, comprising 22% of the workforce, and 890 African American workers, representing 7% of total employment. Each Corsair required 6,800 individual parts manufactured to tolerances Japanese factories struggled to maintain. The massive Pratt Whitney R-2800 engine alone contained 2,100 components, each machined to specifications measured in thousandths of an inch. American factories produced these engines at rates exceeding 1,000 per month by mid-1943, more power plants than Japan's entire aviation industry manufactured in the same period. The assembly process demonstrated American industrial philosophy. Rather than craftsmen hand-fitting components, Vought used standardized parts and precision tooling. Workers with minimal experience could assemble complex aircraft sections using jigs that ensured proper alignment. A woman who had been a secretary 3 months earlier could rivet wing sections with accuracy matching any pre-war craftsman. Mary Parker, 34, former elementary school teacher from Hartford, operated a hydraulic press that formed aluminum wing ribs. She had received 2 weeks of training before starting production work. Her press stamped 1 wing rib every 3 minutes, producing components identical to specifications. Japanese craftsmen formed similar parts by hand, a skilled metal worker spending an hour to achieve what Parker's machine accomplished in minutes. Production rates at Stratford reached 1 Corsair every 8 working hours by spring 1943. The factory operated 2 shifts, 16 hours daily, producing 4 complete fighters each day. Weekly output reached 28 aircraft. Monthly production approached 120 Corsairs from Stratford alone. A single American factory was outproducing Japan's 3 naval fighter plants combined. The evidence was mounting, but Japanese naval leadership refused to believe the implications. June 1943. Imperial Navy Headquarters in Tokyo. Commander Genda presented his analysis to the Naval General Staff. Spread across the conference table were combat reports from 14 separate engagements, pilot testimony from 27 survivors, and reconnaissance photographs of American air bases showing rows of Corsairs. The numbers were staggering. Japanese fighters had lost 43 aircraft in encounters with Corsairs, while achieving only 4 confirmed American losses, a 10.75 to 1 kill ratio in America's favor. Admiral Ozawa studied the documents with visible displeasure. The statistics contradicted everything Japanese naval aviation had accomplished since 1937. How could American industry produce a fighter that reversed the ratio? Genda laid out production statistics. American industrial capacity exceeded Japanese production by a factor of 17 to 1 in steel, 8 to 1 in oil, 5 to 1 in aircraft. The Corsair represented America's ability to design and mass-produce advanced weapons faster than Japan could counter them. Ozawa's response reflected ideological certainty. American workers are undisciplined. American society is decadent. American democracy creates chaos rather than efficiency. These production numbers must be propaganda. To accept that American industrial democracy outproduces Japanese martial discipline is to accept that everything we believe about national superiority is false. Officers who agreed with Genda's assessment remained silent. Speaking truth to power had become dangerous. The culture of the Imperial Navy rewarded certainty and punished doubt. 3 months later, the situation had deteriorated further. American forces landed at Vella La Vella in August 1943, supported by Marine Corsair squadrons. In 3 days of fighting, Corsairs shot down 29 Japanese aircraft, while losing 2 planes to combat and 1 to mechanical failure. The 14.5 to 1 kill ratio represented the worst aerial defeat Japan had suffered. Lieutenant Commander Nakajima filed increasingly desperate reports. His squadron had lost 18 pilots in 6 weeks. Replacement pilots arrived with barely 100 hours of flight time. thrown into combat against American aviators who trained for 300 hours before deploying. Nakajima wrote, "We are not fighting pilots. We are fighting a system that replaces losses faster than we can inflict them." Petty Officer Matsumoto noted in his diary from September 1943, "The pilots drink more sake each night. They do not speak of tomorrow's missions. When the alert sounds, I see fear in faces that once showed only confidence. The Americans have broken something beyond aircraft. They have broken belief." Lieutenant Aoyagi's diary entries reflected similar demoralization. "We scramble knowing we will lose friends today. The new pilots last 3 missions on average. Then they are dead or missing, and new faces appear who will also be dead in 2 weeks. The Americans replace their losses within days. Our losses are permanent." A second major Corsair factory opened in Dallas, Texas, in July 1943. The Chance Vought plant at Grand Prairie covered 1.4 million square feet, larger than the Stratford facility. The Dallas facility employed 18,200 workers by year's end, including 4,800 women representing 26% of the workforce and 1,640 African American workers comprising 9% of total employment. Elizabeth Chen, 29, Chinese-American assembly supervisor from Los Angeles, managed a team of 43 workers installing Corsair electrical systems. Her crew included former waitresses, bank clerks, and housewives. Chen's team wired 1 complete aircraft every 10 hours, installing 2.8 miles of electrical cable per fighter with error rates below 0.1%. Combined output from Stratford and Dallas reached 402 Corsairs in October 1943, 428 in November, 461 in December. Monthly production exceeded what Japanese intelligence believed possible for annual production. This single American aircraft type outproduced every Japanese fighter factory combined. Reality would not wait for acceptance. October 12, 1943, a Corsair from VMF 215 suffered engine damage during a strike on Bola Island. First Lieutenant Robert Hanson ditched in waters controlled by Japanese coastal forces. The aircraft sank in 40 feet of water. Japanese naval infantry recovered substantial sections, including portions of the wing structure, cockpit armor, and engine components. The debris arrived at Rabaul within 48 hours. Warrant Officer Ito supervised the examination. The wing section revealed construction techniques that shocked him. Rather than hand-fitted components Japanese craftsmen produced, the Corsair used standardized parts and riveting patterns suggesting mass production techniques. Every rivet hole, every structural joint appeared identical to machine-made precision. Ito measured the wing skin thickness, 0.064 inches of aluminum alloy, thicker than the Zero's 0.043-inch skin. The structural spars showed different design philosophy. Where Japanese engineers minimized material to reduce weight, American designers used heavier structures that sacrificed some performance for durability. A Zero wing hit by .50 caliber fire would likely fail structurally. The Corsair wing absorbed punishment and continued flying. The cockpit armor proved even more revealing. A steel plate measuring 0.38 inches thick protected the pilot's back and head. Punner calculated the weight. Approximately 47 pounds of armor in the cockpit area alone. The entire Zero fighter weighed 4,100 pounds empty. The Corsair carried armor exceeding 1% of the Zero's total weight just to protect the pilot. The engine components proved most significant. The cylinder head castings demonstrated metallurgy exceeding Japanese capabilities. The supercharger impeller showed machining tolerances Japanese factories struggled to achieve on prototype engines. Yet these precision parts came from operational aircraft built on assembly lines. When Ito measured the engine components against Japanese engine standards, the disparity became mathematical. The R-2800's connecting rods were machined to tolerances of 0.005 inches. Japanese equivalents managed 0.02 inches on their finest engines, 4 times more precise, produced in quantity, installed in fighters built faster than Japan could manufacture training aircraft. He prepared a technical analysis for Commander Nakajima, spanning 14 pages. The Corsair's construction revealed industrial sophistication Japan couldn't match. This wasn't merely quantity overwhelming quality. This was superior quality deployed in mass production quantities. Seaman Nakamura assisted Ito during the examination. He wrote in a letter to his brother, "The Americans build their fighters like we build battleships. Every part is strong. Every system is redundant. Everything is designed to survive damage and continue fighting. Our fighters are beautiful but fragile. Theirs are brutal but unstoppable." When salvaged components were tested, results exceeded even optimistic assessments. The armor plate protecting the cockpit, when subjected to firing tests using Japanese 20mm cannon rounds, stopped those rounds at combat ranges. Every physical test confirmed American engineering superiority. Itoru's report reached Tokyo in November 1943. Naval engineers reviewed the evidence with dismay. If these specifications were accurate, Japan faced insurmountable disadvantages. Lieutenant Commander Shibata, who had dismissed earlier reports as propaganda, examined Itoru's physical evidence and could no longer maintain denial. Japanese attempts to reverse engineer Corsair technology failed immediately. The metallurgy required alloys Japan couldn't produce in quantity. The precision manufacturing demanded machine tools Japanese factories didn't possess. The engine specifications required industrial infrastructure that would take years to develop. But the physical evidence was dwarfed by what came next. November 11, 1943. The Battle of Empress Augusta Bay. Japanese Admiral Sentaro Omori ordered airstrikes against American invasion forces at Bougainville. Commander Nakajima led 67 Zeros, escorting 18 bomber aircraft toward the beachhead. Intelligence reports suggested limited American air cover, perhaps 24 fighters. At 11:15 hours, American radar operators detected the Japanese formation 80 miles from target. Marine Fighter Squadron VMF-214, commanded by Major Gregory Boyington, scrambled 24 Corsairs to intercept. Additional Corsair squadrons launched from Vella Lavella and Baracoma. Within minutes, 48 Corsairs climbed toward Nakajima's force. The Corsairs struck from above at 1:42 hours, diving through the bomber formation at speeds exceeding 400 knots. The first pass destroyed 4 bombers and 2 Zeros before the Japanese fighters could react. Major Boyington's 6-gun salvo ripped through a Zero's fuel tank, the aircraft exploding in a fireball. His wingman, First Lieutenant Robert McClurg, destroyed a bomber with a 3-second burst. Nakajima ordered his pilots into defensive formations, the tight weaves that forced attacking fighters into sustained turns. The Corsairs didn't turn. They dove, fired, and climbed back to altitude, repeating the pattern indefinitely. Every time Zeros positioned for attack, the Corsairs accelerated away, climbing beyond pursuit range. Lieutenant Iwamoto attempted to intercept Corsairs during their climb out. His Zero turned hard, cutting across the American fighter's flight path. The Corsair pilot simply pushed his throttle forward. The big fighter accelerated in a climb the Zero couldn't match. Iwamoto fired his cannons at extreme range, achieving no hits. When Japanese pilots scattered to avoid attacks, the Corsairs dove again, targeting isolated aircraft. Lieutenant Awoyagi found himself separated from his wingman, 2 Corsairs diving toward him from opposite quarters. He turned hard left to evade the first attacker. The second Corsair adjusted its dive angle and opened fire. Awoyagi's Zero absorbed 17 50-caliber hits, his right aileron shredded, his canopy shattered, his instrument panel destroyed. He nursed the crippled fighter back to Rabaul at treetop level. The battle lasted 23 minutes. Of 67 Zeros that began the engagement, 23 crashed. 11 more suffered damage requiring immediate landings at forward airfields, where most were written off. The bomber formation lost all 18 aircraft. Nakajima survived with a damaged aircraft and shattered confidence. The Corsairs lost 3 aircraft total. 1 suffered engine damage from defensive fire. Another took flak hits that damaged hydraulics. 1 crashed on landing due to mechanical failure unrelated to combat. The kill ratio exceeded 11-1. Major Boyington's combat report noted, enemy fighters attempted to engage in turning combat but broke off when attacked from altitude. Speed advantage allowed engagement at will. Ammunition expenditure 1,1250 rounds per aircraft average. 32 confirmed kills, 6 probables. Lieutenant Sakai, who escaped by diving to sea level, wrote in his diary, "We cannot fight them. They choose when to attack, when to escape. Our maneuverability means nothing. Today I understood we will lose this war." Petty Officer First Class Yamamoto Isao, who survived despite his Zero taking 17 hits, provided testimony. "I counted 40 seconds from when the American dove until he climbed beyond range. In that time he fired perhaps 400 bullets at us. Then he climbed to safety, and we could not follow. 10 minutes later, he dove again. How do you fight an enemy who attacks when he wishes and escapes when he wishes?" American fighters expended 60,000 rounds of .50 caliber ammunition during the battle. Each Corsair carried enough ammunition for multiple attack passes. Japanese Zeros exhausted their supply after 2 or 3 engagement attempts. Quantity had achieved a quality all its own. The Corsair produced American aces at rates Japanese training programs couldn't match with replacements. First Lieutenant Robert Hanson, whose ditched Corsair Japanese forces had recovered, returned to combat in November 1943. Flying with VMF 215, Hanson achieved 25 confirmed victories in 17 combat missions. His technique emphasized altitude advantage, high-speed attacks, and immediate disengagement. Hanson never entered turning combat with Japanese fighters. On February 3, 1944, his Corsair was hit by anti-aircraft fire during a strafing run. He died when his aircraft crashed. Major Gregory Boyington accumulated 28 confirmed victories, 22 while flying Corsairs with VMF 214. His aggressive tactics and leadership created the most effective fighter squadron in marine aviation. He was shot down on January 3, 1944, during his final mission, captured by Japanese forces, and spent the remainder of the war as a prisoner. First Lieutenant Kenneth Walsh achieved 21 victories flying Corsairs with VMF 124. Walsh developed high-altitude interception tactics that maximized the Corsair's performance advantages. He survived being shot down twice. Walsh received the Medal of Honor for actions on August 15 and 30, 1943, when he single-handedly engaged formations of 20 and 50 Japanese aircraft respectively. Second Lieutenant Ira Kepford flew with VF-17, achieving 16 victories in 4 months. His technique emphasized deflection shooting and energy management. Kepford survived the war and returned to civilian life. Captain Donald Aldrich flew Corsairs with VMF-25He, achieving 20 confirmed victories. His tactical approach combined aggressive offensive action with careful risk management. Aldrich survived the war, having never been shot down. Japanese pilots watched these aces operate with growing despair. Lieutenant Aoyagi wrote, "The American leader flies with absolute confidence. He knows his aircraft is superior. He attacks when he chooses and escapes when he wishes. Our best pilots die trying to engage him. He returns day after day while we bury friends weekly." December 1943. Knowledge of the Corsair's superiority spread through every level of Japanese naval aviation, from Admiral Ozawa in Tokyo to Petty Officer Matsumoto at Rabaul. The truth could no longer be denied. Commander Genda prepared a final assessment for the Naval General Staff. Japan produced roughly 20 fighter aircraft daily across all manufacturers. America produced 80 fighters daily, and that number was increasing. Japanese training programs graduated 100 pilots monthly with reduced flight hours due to fuel shortages. American programs graduated 800 pilots monthly with double the training time. Even fanatical officers acknowledged reality. Captain Okumiya submitted a report in January 1944, stating, "American industrial capacity has created a situation where tactical excellence cannot overcome material disadvantage. The Corsair demonstrates that democratic societies can outproduce totalitarian nations when fully mobilized. Our ideology insisted this was impossible. Combat results prove our ideology was wrong." What Japanese planners couldn't see was the diversity advantage underlying American production. At the Vought factory in Connecticut, workers represented 47 different nationalities. Women comprised 22% of the workforce, operating complex machinery and assembling intricate components with precision matching male workers. African American workers, immigrants, disabled veterans, teenagers too young for military service, all contributed to production that outpaced anything Japan's ethnically homogeneous, male-dominated workforce could achieve. Margaret Johnson, 42, disabled in a car accident that cost her left leg below the knee, operated quality control instruments at the Dallas plant. Her disability disqualified her from most wartime work, but aircraft inspection required sharp eyes and steady hands, not legs. Johnson inspected 16 Corsairs daily, catching defects that would have caused failures in combat. Letters home spread awareness of Japanese disadvantage. Lieutenant Ayagi wrote to his brother in January 1944, "We are losing this war in the sky. The Americans build fighters faster than we can destroy them. For every Japanese pilot who survives combat, 3 die or are crippled. For every American pilot who dies, 3 more arrive to replace him. The mathematics are simple and fatal." Petty Officer Matsumoto's diary entry from February 1944 noted, "The new pilots are children, 18 years old, barely able to land without crashing. They have 60 hours of flight time. The Americans we face have 300 hours of training. Our boys die on their first mission. The Americans survive to become experts. I maintain aircraft for ghosts who will be dead before I see them again." Intelligence analysis revealed the scope of failure. A single American factory outproduced all Japanese aircraft manufacturers combined. 3 American engine plants manufactured more power plants monthly than Japan's entire industry produced annually. American training programs graduated more pilots monthly than Japan's entire wartime training program produced. American students flew 300 hours before deployment. Japanese students received 100 hours if fortunate, rushed through abbreviated training to fill combat losses. By March 1944, even leadership could no longer maintain denial. The Corsair had destroyed Japanese air superiority through systematic advantages, superior performance, overwhelming firepower, infinite replacement capacity. The material disparity extended beyond aircraft performance. American bases in the Pacific operated with abundance Japanese forces couldn't imagine. At Vella La Vella in early 1944, Marine Corsair squadrons received fresh provisions daily. Pilots discarded food they didn't like, throwing away portions that would have fed Japanese soldiers for days. Petty Officer 2nd Class Koji Suzuki, captured in February 1944, observed American eating habits with disbelief. He later testified, "They threw away more food in one day than my unit received in a week. Half-eaten cans, fruit with bruises, bread because it wasn't fresh. We were starving. They were wasteful. This abundance broke my spirit more than combat." American Corsair pilots flew to training missions carrying extra ammunition, expending thousands of rounds on practice targets. Japanese pilots counted every bullet, firing only when hits were certain. Captured Japanese pilot Lieutenant Hiroshi Nishizawa testified after the war, "American pilots told me they could request any ammunition they wanted. I asked how this was possible. They looked at me with confusion, as if the question made no sense. Abundance was normal to them. Scarcity was unthinkable. Fuel abundance demonstrated the disparity starkly. American Corsairs operated without fuel restrictions. Pilots could fly training missions daily, building experience and proficiency. Japanese pilots received minimal flight time due to fuel shortages. Veterans rarely flew except on combat missions. Training became impossible. Skills atrophied. Meanwhile, American pilots improved continuously. During the Battle of Empress Augusta Bay, Corsairs expended an average of 1,050 rounds per aircraft. Japanese Zeros carried 680 rounds total across both machine guns, plus 120 cannon rounds. A single American fighter expended more ammunition in one battle than a Zero could carry in 5 flights. When VMF 214 lost 3 Corsairs in combat during November 1943, replacement aircraft arrived within 5 days. The squadron returned to full strength before the next major operation. Japanese squadrons that lost 3 aircraft waited months for replacements, operating below strength indefinitely. April 1944, Admiral Ozawa, now commanding the mobile fleet, acknowledged what he had denied for 18 months. In a briefing to senior commanders, he stated, "American fighters, particularly the Corsair, have achieved performance superiority our aircraft cannot match. Their production capacity exceeds our entire industrial base. We face an enemy who builds fighters faster than we can destroy them, trains pilots faster than we can kill them. This is not defeatism, this is mathematics." The truth spread through multiple channels despite official censorship. Combat pilots returning from forward bases described encounters with Corsairs in terms that shattered propaganda claims. Training instructors whispered that new pilots had no chance against American fighters. Maintenance personnel compared the robust construction of captured American equipment against the increasingly fragile Japanese aircraft they serviced. Japanese medical officers documented psychological effects they termed Corsair syndrome. Pilots developed stress symptoms before missions, knowing they would encounter aircraft they couldn't defeat. Physical manifestations included tremors, insomnia, digestive problems, and panic attacks. Refusal rates increased. Some pilots deliberately crashed on takeoff, accepting injury as preferable to combat they knew was suicide. Navy psychiatrist Lieutenant Commander Takeshi Yamada filed reports documenting the psychological collapse. In March 1944, he wrote, "The pilots know they will die, not that they might die, but that death is certain. This knowledge destroys the warrior spirit we depend on. They fly because duty demands it, but they fly without hope. Combat effectiveness requires belief in possible victory. When victory becomes impossible, the pilot becomes a passenger in an aircraft flying towards certain death." May 3, 1944, a small engagement over truck demonstrated how thoroughly knowledge of defeat had penetrated Japanese consciousness. 6 Zeros intercepted 4 Corsairs attacking supply vessels. The Japanese pilots possessed numerical advantage but didn't press the attack. They made one pass, fired briefly, then broke off when the Corsairs turned to engage. The Japanese pilots fled, abandoning the ships they were supposed to protect. Warrant Officer Ichiro Nakamura, one of the Zero pilots, recorded his reasoning in a diary later captured. "We fought because we were ordered to fight. We knew we would lose. The Corsairs are faster, better armed, better protected. Their pilots are well trained and confident. I flew today knowing I would likely die. That I survived means nothing. Tomorrow's mission will kill me, or the next day's. The mathematics are certain." Petty Officer Matsumoto recorded the increasing nihilism in his diary from June 1944. "The pilots no longer maintain their aircraft. They used to inspect every detail. Now they accept whatever aircraft is assigned and fly it without comment. Why inspect when you will die regardless? The mechanics try to maintain standards, but the pilots have surrendered to fate." June 1920–1944, the Battle of the Philippine Sea. Known to Americans as the Great Marianas Turkey Shoot, Japanese naval aviation launched its final offensive, throwing every available aircraft against American carrier forces. The Japanese committed 373 carrier aircraft and 43 land-based aircraft. American forces deployed 450 fighters, including 76 Corsairs operating from escort carriers. American fighters, including Corsairs using their altitude and speed advantages, decimated Japanese formations before they reached American ships. Japanese aircraft losses exceeded 300, including many pilots who represented the last trained veterans of carrier aviation. American losses totaled 29 aircraft, most to anti-aircraft fire rather than aerial combat. The 10-to-1 loss ratio represented complete Japanese defeat. Admiral Ozawa reported to Combined Fleet Headquarters, "American air defenses are impenetrable. Their fighters intercept our formations at ranges exceeding our previous experience. Their aircraft performance exceeds our capabilities. The carrier air groups have been destroyed. Replacement will require years we do not have. The war in the air is lost." Complete Japanese tactical helplessness became visible. Japanese formations scattered when American fighters appeared, abandoning tactical discipline in desperate attempts to survive. Pilots jettisoned bombs and torpedoes to flee faster. Nothing Japanese pilots attempted mattered. Every tactic failed. Every formation was broken. Vice Admiral Takajiro Onishi stated in July 1944, "Conventional tactics cannot defeat American air power. The Corsair and similar American fighters have created air supremacy we cannot challenge through normal operations. Only special attack methods offer any possibility of success. We must use our aircraft as guided weapons because we cannot use them effectively as fighters." The Special Attack Units, the Kamikaze program, emerged from this realization. When fighting couldn't succeed, suicide became strategy. The transition from confident air superiority in 1942 to desperate suicide tactics in 1944 measured the complete collapse of Japanese aerial capability. The war ended with statistics that documented American aerial superiority with mathematical precision. From January 1943 through August 1945, American factories produced 12,571 Corsairs. Japanese manufacturers produced 10,939 Zero fighters during the same period, but the Zero's combat effectiveness declined while the Corsairs improved. By war's end, Corsairs operated from 20 aircraft carriers and 43 land bases across the Pacific. The kill ratio became legendary. Corsairs achieved 2,140 confirmed aerial victories against Japanese aircraft, while losing 189 aircraft to enemy fighters. The 11.3-to-1 ratio remained consistent across 3 years of Pacific combat, from the Solomons through the Philippines to Okinawa and Japan itself. Production comparisons revealed the industrial gulf. American factories produced 304,000 military aircraft during the war, including 99,000 fighters. Japanese industry manufactured 76,000 military aircraft total, including 30,000 fighters. The Americans built 4 times as many aircraft, and those aircraft generally outperformed Japanese equivalents. Casualty statistics told the human cost. Japanese naval aviation lost approximately 19,000 pilots killed in combat, with thousands more dying in training accidents. American naval aviation lost 6,800 pilots killed in Pacific combat, a terrible toll, but one that represented 1/3 the Japanese rate despite more intensive operations. The Americans replaced their losses and expanded their force continuously. The Japanese losses accumulated until no combat-effective force remained. Economic comparisons showed the resource disparity underlying everything. The Corsair program cost approximately $850 million from development through production. Japan's entire fighter development and production budget for 1942 to 1945 totaled roughly $600 million. A single American fighter program outspent Japan's complete fighter aviation effort. Military historians estimate the Corsair shortened the Pacific War by approximately 6 months through air superiority that enabled amphibious operations to proceed ahead of schedule. Those 6 months represented hundreds of thousands of lives saved, both Allied and Japanese. 1978, San Diego, California. The annual reunion of Marine Fighter Squadron VMF-214. Saburō Sakai, now 62, attended as an honored guest. The former Imperial Navy ace had survived the war despite being shot down 3 times, partially blinded in one engagement, and hospitalized for months with wounds that should have killed him. He had moved to America in 1952, working as an industrial designer and writing memoirs that provided Japanese perspectives on the air war. Sakai met Colonel Gregory Boyington, retired, the former Marine major who had commanded VMF-214 during the battles over Bougainville. The two men had possibly faced each other in combat on November 11, 1943, though neither could confirm the encounter specifically. They shared drinks, discussed aerial tactics, and acknowledged the complex legacy of their wartime experiences. Boyington asked Sakai about Japanese perceptions of the Corsair. Sakai's response captured the transformation Japanese pilots experienced. "We laughed when we first saw the Corsair. The bent wings, the size, the ungainly appearance. We thought it looked like a mechanical bird that couldn't fly properly. We stopped laughing after the first battles. Within 3 months, we feared it more than any other American aircraft. The Corsair showed us that our assumptions about aerial combat were wrong, that our ideology about American weakness was wrong, that our confidence in maneuverability over power was wrong." Boyington's response reflected matter-of-fact professionalism. "We had better equipment, better training, better support. You guys were tough pilots with a bad aircraft and no replacement capacity. The Corsair gave us advantages we used well, but the real difference was the system behind the fighter. We could lose planes and get new ones within days. We could lose pilots and get replacements within weeks. You couldn't match that even if your fighters had been equal." The exchange revealed something both men understood. The Corsair was a symptom, not the disease. Japanese defeat stemmed from systemic disadvantages: industrial capacity, resource availability, training infrastructure, and strategic planning. The fighter aircraft merely made those disadvantages visible through combat results that couldn't be rationalized or denied. Sakai reflected on the racial ideology that had blinded Japanese leadership. "We were taught that Americans were soft, divided, inferior. The Corsair proved that democratic diversity was stronger than authoritarian unity. Your factories employed women, minorities, immigrants, disabled workers, people our military dismissed as inferior. Those workers built fighters that dominated our pilots. The lesson was painful but necessary. Saburō Sakai began February 14, 1943, believing Japanese pilot quality and aircraft maneuverability would determine the Pacific Air War's outcome. He ended the war in August 1945, having witnessed the systematic destruction of those assumptions through encounters with an aircraft that refused to fight on Japanese terms. Japanese pilots laughed at the Corsair when intelligence photographs first reached Rabaul in early 1943. By mid-1943, those same pilots fled when Corsairs appeared. By war's end, Japanese pilots refused to engage Corsairs except when directly ordered. The Corsair proved that in modern warfare, industrial capacity defeats martial spirit. The 11-to-1 kill ratio represented the cumulative advantage of better resources, better training, better support, and better strategic planning. The fighter that destroyed their comrades had taught a lesson about modern warfare that remains valid. In industrial conflict, production capacity determines victory more than any other single factor.